Welcome to Robotic Mechatronic System Design, ROBT402, Lecture 1, Introduction to Mechatronic Systems and MPS 500. I am Mohammad Musaddiqzad and I am the instructor of the course. Today's topics are as follows. Demo of the MPS 500 setup, simulation of an automated storage, syllabus, books, software simulation, safety considerations, emergency stop buttons, safe behaviors, and safety in working with pneumatic devices. So although we don't have access to the lab and the equipments, I don't want to cut the materials, for example, safety. Why? Because anyway, later when you will join a workspace and industry and going to work as an engineer, it's good to know safety mechanisms and switches and behaviors. So we will do our best to keep the material as usual, as you have access to the lab, and try to replace as much as we could with simulation. But we need to show lots of videos and pictures to give you a same sense of feeling as you have access to parts and devices. Okay, so this video shows a demo of MPS 500 setup. Why exactly this one? MPS stands for Modular Production System, and this is a system designed by Festo and equipped it with a different type of PLCs. The one we had and we have in the lab, Intelligent Manufacturing Lab, is equipped with Siemens PLCs, but there are different versions of these systems with Festo PLCs, with Allen Bradley PLCs and other types of PLCs, plus the robotic arm is also equipped with different vendors and manufacturers. The one we have in the lab is made by Mitsubishi, but I've seen different type of MPS 500 equipped with different manipulators and robotic arms. So the concept is same. We have different stations. Okay, so we have different stations, and each stations have a specific task. And here we have a core conveyor that carries all of these pallets and parts between each stations. We don't want to stick particularly to this specific system in this course, because anyway we don't have access to this system as we used to, but it is a very good example and shows how a manufacturing system, an assembly line works. So through the course, we will use different basically stations to design let's say pneumatic circuit or electrical circuit, try to simulate it and write PLC programs. We will use both codices and TIA to program PLCs. So PLCs usually located here in this boxes for the system. So, and this small window here shows you the real system. Okay, and for example, Festo PLCs could be programmed by codesys. Okay, but Siemens PLCs, because they are closed hardwares and they have a closed architecture design, they should be only programmed by TIA portal. So we'll do our best to cover both of these programs, but since codesys doesn't have license and is free to use, so we have to switch mostly to codesys throughout this course. But anyway, we will use a 1 month trial version of TIA portal, and we will have some exercises and example on TIA portal as well. So we have lots of pneumatic devices and actuators and valves. We will talk about pneumatic parts on this course. We will talk about different type of sensors. Again, we'll use MPS 500 as a show, as a basically case example for any automation systems. But the concept is the same. We'll have very similar sensors in any, let's say, factories, in any assembly lines, in any production lines. So we will cover the sensors and the actuators, pneumatic actuators and the pneumatic valves. We will stick to the pneumatic one, but the hydraulic valves and actuators are very similar, and you are also provided by Festo-Fluid-Sim hydraulic, so you could design and simulate hydraulic systems as well. Okay, so let's watch the video and see what we have in this system. So you see these pallets are moving on this conveyor at the center, and when this pallet arrives at this station, the part will be fitted onto the pallet, and the pallet will move the part to the next station. So this station is a distribution station. This station is a testing station. So why distribution station? Because we have a magazine here, and we have parts on this magazine, and we have a swivel that fits the part into the elevator. This is the elevator, and the part finally basically will be tested by some sensors and will be passed to the pallet. Pallet will move forward, and then we have a handling station. In the handling station, basically, the part will be picked from the pallet and will be placed on the processing station. We have this rotary stage part that moves the part between different stages, and they will do the polishing and drilling. So let's continue. Okay, so now the pallet arrived. So you could see at the same time what's happening in the real system. Here is the magazine, and the piston basically fits the part forward. Okay, so now the part is outside of the magazine, and we have a vacuum here that picks the part, and the swivel, which is a semi-rotary pneumatic actuator, will move the part to the elevator, which is located on the testing station. Again, this one is distribution station, and this one is a testing station. So you see on each of these stations, we have a couple of switches. We have start, stop, auto manual, and we have some LEDs. We have start LED, we have reset LED, and we have an indicator LED. Okay, so these LEDs and switches are inputs and outputs to the system. Operator could stop the system by pressing the stop button, or could start the system by pressing the start button, or start and reset LEDs could be used in the PLC programming to indicate some signs. For example, the system is ready to be started when it's blinking. Okay, so then the operator knows that this is time to start the system. Or there is an error and the reset LED starts to blinking, yes? So then the operator knows that something is wrong in the system and should stop the system. So you could see we have pneumatic valves, okay, on the system. We will see the real picture of these valves in the coming sessions and slides. And we have a couple of actuators. We had one piston that fits the part from the magazine forward, and we have this semi-rotary pneumatic actuator that passes the part to the next station. We have also the vacuum. We have pneumatic vacuum here. And we have lots of sensors. Yes, we have limit switches. Here we have inductive sensors, okay, and other sensors that we will discuss in coming slides. So why particularly again these stations and this system? Because this is a small scale factory, and you will see similar and equivalent parts in the big factories. So it doesn't matter what size of actuators is or what forces and power they have. Anyway, the concept is same for pneumatic circuit design point of view, from the electrical circuit design point of view, from the PLC programming point of view. And if you learn these systems, then you could work with the bigger ones. Okay, let's continue. Now you see the elevator came down. Now it's ready to pick the part. Part is placed on the elevator here, and then you see that it goes up. Okay, so it goes up, and we had a couple of sensors, inductive sensors in the testing station. That's why we call it testing station. We have photoelectric sensors to check the color, to check the material, and we have basically the elevation or height sensor that checks the height of the part. So if the part is okay, then it could be fitted to the pallet. So you see the pallet moves forward. Now is stop here at this station. We have a stopper that stops the pallet when the pallet arrives at this station, and we have these photoelectric sensors that sense the part, and now the handling station picks the part and moves the part to the processing station. So why we call it processing station? Because we want to work on the part and make it ready. For example, we want to drill a hole on the part. We want to do the polishing on the part. And then finally, when the processing is finished, the handling station will move the part back to the pallet. Here we have a vision station. Okay, in the vision station, again, we could check the part visually and see if the part is processed normally, if the part is not defected, so the part could be passed to the assembly station. This is the assembly station. We have this robotic manipulator that works on the part and will again check the part, check the orientation of the part, put a cap on the part, put a piston. This is a piston on the part. So basically it will add some parts. We have these springs here. It picks the springs from the springs magazine, put it inside, and finally there is a cap that is going to be placed on the top of the cylinder. So we have a cylinder, piston, spring, and the cap. So all of these parts should be placed together, and the cap should be basically tightened, and then it could be placed on the pallet and go forward. This is storage. This is a storage station. If the next station is not ready to accept the part, the storage station will pick the part and will put it on these racks. Okay, but if the next station, which is a sorting station, is ready, the part will go straight to the next station. Okay, now we are at the final station, and again we have a handling station very similar to the handling station we had attached to the processing station. Now the part is picked here. And will be placed on this conveyor. Again, the color of the part will be checked. And based on the color, if the color of the cylinder is red or a silver or black, it will go to different slides. Okay, so we are checking the color. The color is red, so it will go to the first slide. So again, this system is designed to simulate a factory. So this is a place to have, let's say, a shipping. Okay, so here we have a packaging and shipping. So let's say trucks are ready at the door of the company to pick the packages and boxes. Okay. If the shipment is not ready to accept more parts, then parts should be temporarily go to the storage, and then later from the storage will be fed back to the system and to the sorting station. So it was one example. There are lots of sensors involved in this process to check the color, to check the existence of the part, to check position of cylinders. Plus, we have lots of actuators. We have DC and AC motors, for example, to rotate the conveyor belt. We have these pneumatic actuators to move these parts around, to do the pick and place. We have these pneumatic actuators here, okay, that basically sorts these parts into these slides. And this is a mechatronic system in general, yes. So it's combination of mechanical parts and electronic parts. We have actuators, we have valves, and we have sensors, and we have PLCs and the logical part, basically. So the conveyor itself also have a controller, and the controller of the conveyor is located here on this box. This box also is equipped with the start, stop, and some indicators and LEDs. All of these switches are inputs to the PLC. Sensor signals are input to the PLC. Actuators and valves are output of the PLC. So PLC should send a command to the actuators and say them what to do and what is the next sequence. But sensors basically provide data to the PLC, and the basically PLC programming use those input data to decide the next sequence, what should happen next. Okay, so here we have simulation of an automated storage. This is another example. Um, this is a simulation in a factory. IO software is a very famous software for automation systems and mechatronic system design and simulation. Unfortunately, very expensive software, and license is not available for free. So I wasn't be able to use this software for this course, but we have some equivalent softwares, and I will explain what softwares we will use, what program we will use to do the simulation and test or mechatronic and robotic system design. So let's watch a video. This is automated storage. This is a storage system here. And we have these conveyor belts. Again, the simulation. Lots of sensors and actuators are involved. Stoppers stop these parts based on the PLC command. Sensors will check the presence of the part, will check the quality of the part, and for example, these boxes could have a barcode and we could have a barcode reader, and based on their barcode, they should be sorted and send it to the different lines. Okay, so you see basically some lasers flashing sometimes. Uh, there could be the different type of sensors or LEDs or basically these barcode scanners. So here, this is automated storage. Uh, Based on the type of the box and the barcode, the parts will be placed in different racks and storage places. Or they could be rejected to the outside if they are not proper, if the label is not proper. Yeah, so it shows a factory, and believe it or not, the automation system is nothing more than some sensors, some actuators, a PLC, which take care of the logic and the sequences of the system. And we could have some pilot lights and, for example, a siren, some inputs and outputs, yes? So nothing more than that. But on top of these, we want to explore pneumatic actuators and pneumatic circuit designs. Why? Because many automation systems are designed by either pneumatic circuits or hydraulic systems and circuits, and it's good to know how to deal with these type of systems, how to command them, how to control them by PLC. Okay, so let's talk about the syllabus and the course in general. Class time, Tuesday, Thursday, 75 minutes. This course is an asynchronous course, so you don't have to be online on these specific times of the class, but I just recommend you to see it and watch on YouTube videos and study the lecture materials and work on the exercises just to keep the discipline, yes, just to have a specific particular time to work on this course. So 2 lectures per a week, and the lectures will be in the form of regular lecture to cover the theory part or a practical one to work with the setup simulation. So in some of the sessions, you will have some exercises that you have to work by your own. Okay, I will provide you with some examples, but then the rest of the exercises should be done on those sessions. Okay, so we have lots of exercises and homeworks and projects that you should do. Okay, because this course is intended to be hands-on. Okay, of course you don't have access to the lab, but you basically could do the simulation and programming by yourself. So we don't have a final exam on this course and is replaced by the final project. Okay, so course textbooks, mechatronic, a multidisciplinary approach, and automating with the SIMATIC S7 1500. These are 2 textbooks, but I will upload a couple of other textbooks like these reference textbooks, Industrial Automated Systems in Instrumentation and Motion Control. So instrumentation and motion control course also will be on Moodle, plus a couple of other books that I will upload. So if you refer to the Moodle and the books folder and the top section, you could have access to all of these books. But do we follow exactly these books? No. Okay, so we don't have a particular reference to stick to that. Okay, so the best reference for you will be lecture materials and video, but you could refer to these books if something is not clear, if you want to, let's say, understand deeply one specific part, or if you want to design your project. And Festo website in general and Festo Mechatronic Assistant. So unfortunately, this is not a free tool, but relevant materials and important materials will be covered on the lectures of the course. Okay, softwares. We have Festo Fluid Sim for pneumatic electrical circuit design, and it's provided for you on Moodle, so you could download it and run it on your PC. It's not a heavy software. It could be easily be downloaded and executed on any laptops and PCs. For PLC programming and simulation, we'll use TIA Portal and Codices version 3 or version 2.3. I will use the last updated version, which is version 3, but feel free to use the older version. Why, I will explain you when it comes to the OPC discussion. Okay, so we have a different option for the OPC. So OPC is a connection between this PLC programming and any basically simulation environment. Okay, even connection between this PLC and factory I/O. Of course, we don't have license of factory I/O, but anyway, you could use OPC to connect that. You could use OPC to connect these PLC programming softwares to MATLAB Simulink. And you could use OPC to connect PLC programming codices or TIA to Festo-Floyd Sim. Okay, so and we have to have an OPC software. I'm going to use this KEP Server EX OPC software, and we will provide you the download link. This link is the main download link, but you have to go through the hassle of registration. But I will provide you the installation file. Okay, all of these OPCs have some advantages and disadvantages. The issue is that all of them they need at least these two. They need license, but this one you have 2 hours to work on the OPC, but then after 2 hours you have to restart the OPC. Okay, so that's why this is the best one, I guess, and it's designed for industrial systems. So in the let's say huge factories and industrial setups, they use this KEP server. Okay, or for the codices specifically, for codices you could use codices OPC DA server. Again, you could install the trial version and it's okay for 1 month, but after 1 month you have to purchase it, but it's very expensive. Okay, so I don't recommend that. So that's why the KEP server is the better option than the codices. And they have these free choice, which is the Festo EZ OPC. 5.7 is the latest version. The issue is that it's tough to make a connection between the latest version of codices, specifically this version 3 with the Festo-Floyd Sim. So if you want to use this one, then you have to switch to the older version, and then easily you could make a connection between the Floyd Sim and the version 2.3. But if you want to use the latest version, and if you have that installed, is really a hassle to switch to the older version. So for now, the best option I have is this KEP server that works on each session works for 2 hours, and I believe it's enough to test your PLC program and see how it works connected with the Festo-Floyd Sim. And if the 2-hour session is expired, then you have to restart the OPC, and again you could work on your simulation. And finally, we have this Cyrus for robot simulation. Again, the issue is that the license is very expensive on this. I have access to the license, but it's a single user license. So I will use it when it comes to the robotic programming, just to show you how we could use these type of interfaces and how we could program robots. But this is not a available software for students. Okay. Okay, so background. Students who had ROBT402 Industrial Automation course has background in PLC and PLC programming in codices. If you haven't had ROBT402, all necessary materials will be covered in the course. However, you could find lots of useful materials on these YouTube channels related to ROBT402 and codices programming. So If you want to learn more about codices, if you want to, let's say, do more exercises, if you have a question that you want to find a quick answer, if you want to see, for example, how timers are used in codices, how counters are used in codices, then you could easily go to these channels and use them to watch a video and help you to understand. Of course, you could come to the office hours and basically ask questions, but alternatively, you could use these YouTube channels. Syllabus and course objectives. After completing this course, you will be able to, the course objective shall be fulfilled by using simulation environment. Analyze, understand, and master the interaction of mechanics, pneumatics, electrical engineering, control technology, and communication interfaces. Use pneumatic linear and rotary drives, pneumatic switches, wire electrical components, use limit switch, optical and inductive sensors, use analog sensors and pneumatic grippers. Program and apply PLC as the controller of a process, use enhanced I/O communications. Program an industrial robot using a teaching pendant and through the programming environment using Cyrus software package and simulate the movements of the robot. Integrate an industrial robot in an assembly process. Teach the industrial robot in complex assembly environment. Program the industrial robot combined with the integration of sensors and additional actuators. Course grading approximately will have 3 quizzes, and some part of the quizzes are basically a simulation and circuit design and programming. Okay. Midterm exam we will have, and it's going to be one only, projects. Approximately you have 2 projects, or I might call it mini projects. Lots of exercises and homeworks, and the final project. On the final project, I expect students to submit a very good report, a video, code, and a nice, basically, a simulation. Okay, so we have the course syllabus here on these slides, but also provided on course specification course, which is placed on Moodle. Week 1 will go to introduction of MPS 500 and demo of their manufacturing line, safety considerations and sensors. Week 2, pneumatic actuators and valves. Week 3, introduction to PLC and air preparation. Week 4, vacuum technology and parts, the PLC I/O interfaces. Week 5, Floyd SIM and circuits, ladder logic programming of PLC. Week 6, programming of timers, counters, and graph programming of PLCs. Week 7, we'll have a midterm project. Week 8, we'll have FPD programming of PLC and SCL programming of PLC. Week 9, introduction to HMI and monitoring and control of MPS 500 station with HMI. Hopefully, I will manage to provide you with a proper HMI simulation environment. I'm working on that to see how it goes. Week 10, introduction to robot in general and Cyrus and industrial robot control with Cyrus. Week 11, from week 11, we'll see and we'll have lots of projects. Okay, so all of these are projects that students use to program different stations of MPS 500, but we don't have to necessarily stick to these stations. I could either provide you with the electrical and pneumatic circuit, so you have to design it in FestoFloidsm and program it, and with either Codesys or TIA, and then connect them together and test your program and pneumatic design. Or I could provide you with other industrial system or automation systems, and then you have to basically design the electrical and pneumatic or hydraulic system and program it with a PLC. And so from this week, I could say it will be mostly on you to work on those mini projects and exercises, and finally we'll have the project week or the final project that you have to accomplish a bigger project, a more complex and advanced mechatronic circuit and design, and then submit it on Moodle. I will be available online and Moodle on those particular office hours and separate hours dedicated to this course. If you have any questions, you could come to the Google Meet channel, and we could have a discussion, and you could have a question. So feel free to come anytime on those sessions and ask your questions. If I don't see any students on those channels on those, it's basically Google Meet channel, I won't stay idle. Okay, so I might close the channel, but just shoot me a message on either Telegram or email, and then I will back to the room, to the Google Meet room immediately, and then we could have discussion. Okay, so I'm going to go to some safety consideration. I know you don't have access to the lab, but anyway, in future, soon you will join a factory, a company, okay? So you need to know a basic safety considerations. And one of the basic ones are emergency stop buttons. The emergency stop buttons are located in different locations, as you can see in below pictures. Make sure that you know their locations and how to activate them in case an emergency situation occurs. They are always big red buttons, so very similar everywhere in every factory, okay? To release them after the emergency situation, you need to rotate them clockwise a little bit. So in case of emergency, just press these switches and basically it will stop the system. For example, here for all lab, this is the main emergency switch that if you push this one, it will shut down the whole lab. Okay, but don't hesitate in case of emergency, even in real factories and manufacturing line. If you see a life in danger, if you see that a danger is coming, just push these emergency buttons and don't worry about the rest or any other consequences. For example, delay in the production line. It doesn't matter. The human safety is the most important thing. Okay, so these are also these emergency stops that take care a section of the lab, a specific section, not all the lab. Or for example, here, this is the MPS 500, one of the emergency stop buttons. If on this MPS 500 specifically, if you press any of the emergency stop buttons, it will shut down the whole system, okay, which is okay, okay. But in different factories, those emergency buttons could be dedicated to a specific line or a section of the company, and you should be aware of that. what is or what part of the manufacturing line is under control of that emergency button. Okay, here, for example, this is a assembly station. This is or a robot, a Mitsubishi robot, and this is a controller of that robot. You could see again these emergency buttons on the controller of the robot on the station, and even this one, if you press this one, it will shut down the whole system. Again, this is a controller of the robot, and you see the emergency button. So you could see these arrows here that shows that after you press the emergency button, if you want to release it, you should basically turn it clockwise and then release it. Okay, otherwise you cannot release the emergency stop button. Or on the teach pendant of the robot, this is the teach pendant of the robot, and all robots, industrial robots or educational robots have a teach pendant, are used for programming or controlling of the robot, and will be used by the operator of the robot. And again, we have this emergency stop button. On this teach pendant, because robots are very sensitive, they are extra emergency methods, okay, a way to stop the arm, specifically on industrial robot, heavy industrial robot. When if they go crazy for any reason, could be very, very dangerous. That's why they have usually a cage that separate access of laborers and workers to the industrial robots. So for any reason, for example, if one sensor breaks and robot could go crazy, so operators should be able to stop it immediately. That's why these teach pendants are equipped with alternative methods of stopping the robot. Okay. For example, for this one, we have a dead man switch. Many of the teach pendants are equipped with the dead man switch. I will explain what is this one when it comes to the robot, or this enable switch. Okay, so these are alternative methods to stop the robot. General safety instructions, not in the intelligent manufacturing lab, but in any industrial environment. So you should be either the operator and should be either let's say instructor how to use that machine, or you should keep distance from moving parts, and don't lean to conveyor and stations and moving parts. Don't pull the robot arm. Okay, as I said, industrial robots are usually placed in the safety cage, so you cannot have access. So don't try to, let's say, sneak in and go and let's say touch the robot. Okay, if you are not authorized to enter that cage, don't go. Do not push your friend or colleague while observing or working on a station. Keep a distance between yourself and others. Tie your long hair. It could trap on moving parts like conveyors, pulley, or pulled by a moving arm or object. So specifically important for those who have long hair, either men or women, doesn't matter. Tie up the loose part of clothes by tightening your shirts, buttoning cuffs, or rolling your sleeves tightly. So usually operators and workers wear a specific work suit, but even on those ones, you should be careful that there shouldn't be any loose parts. Don't try to operate the machine or robot unless you receive the instructions or are supervised by the instructor. Pneumatic or electrical actuators could move very fast. Always stay away from direction of their movement. So this one specifically, don't assume yourself an operator if you join a company. Just because you have passed this course or you have some knowledge about mechatronics, you should know specifically the manual of that machine, and you should know the consequences and the program, and you should know how to operate and expect the sequences of the machine. Otherwise, it would be very, very dangerous. Pneumatic parts and hydraulic parts are very powerful and move very fast. So always stay away from those ones, specifically if you don't have knowledge and didn't get the instruction. In case of emergency, try to reach an emergency button and push it. Never download the PLC program without receiving the prior confirmation from the instructor. Okay, so this one is particularly for all lab, but also in the future, when you start to program PLCs in a company, you should get instructions first and then try to test your program on the real system. First, use the simulation. Different type of simulation, different type of testing without downloading directly to the real system, because you could either break a very expensive system or you could put others in danger and even kill others. Okay, so safety comes first.